Hello class, this is an example of how we would want to use a normal distribution to find then a percentile or a value of a percentile rather than a probability. So suppose x is a random variable that describes the monthly rainfall of a particular city. We find that x is then normally distributed with a mean of 7 inches and a standard deviation of 2 inches. So the first thing that we should always do is we should always draw our distribution or just kind of define our variables. So again, mu is equal to 7 and our standard deviation is sigma equal to 2 inches. Okay, so let's go ahead and draw this distribution before we even look at what type of problem we're going to be doing. And we know that here our center, our mean, is equal to 7. Then up from that, we have 1 standard deviation up is about 9, 2 standard deviations up is 11, 3 standard deviations up is then 13, and then going in the negative direction, 1 standard deviation down is 5, 2 standard deviations down is then 3, and 3 standard deviations down is simply just 1. So now that we've drawn our distribution, let's go ahead and look at what the question is asking. We want to know what value separates the 70% rainiest months from the rest. Okay, so what does rainiest mean? It means probably the more rain, correct? So that would be this direction. So if we want to know essentially the top 70% from the rest, where is that going to lie? Well, about 70, so if this is about 50% of our data, or it is 50% above our mean or our median, our center, because this is a symmetric distribution, so 50% of it, the data falls above here, and we know that within the first standard deviation from our mean, 68% of our data lies here. So essentially what that means is about, what, 34% is within here. So we're going to think that about 70% above will be right around here. And this is just kind of an estimate, so it doesn't have to be exact because we're going to calculate the exact value. So essentially we're looking for this area because this would be then the top or the 70% most rainiest months. And we want to then find this value. What value is here? So that's our question. Well, the thing is that this 70% is here, then what's left over here? Our complement would then be 30%. Well, given the values in a z-table always give us the cumulative up from the smallest value up to the largest, we want to then find essentially the 30th percentile in this case. So here, if we want to find the 30th percentile, how can we find that value? This is then going to give us this value that cuts off the lower 30% and the upper 70th percent. Well, we know that the probability of then x being less than our mystery value, let's call this A. So this guy is equal to A, our unknown, is then equal to 0.30. Okay. So before we do anything, let's go ahead and standardize A. So the probability of Z being less than A minus our mean of 7 divided by our standard deviation of 2 is then equal to 0.30. This is the probability. So we've gone as far as we really can. We actually just now need to know what is the small z value that, or the z-score, that is going to give us an area below it of 0.30. Well, we can actually find this on our z-table. So let's go ahead and go over to the z-table. And we need to look through the areas here to find the closest to about 0.3. So it doesn't look like we're too close. We're getting closer once we get down here. Not quite there yet. Keep scrolling. And I see 0.28, 0.276, 0.3084. This is a pretty close one. Go down a little bit more, we see 0.29806 and 0.30153. So really, I'm going to choose this one is the closest essentially to about 0.30, and that means that my z-score associated with this is negative 0.5, and scroll up the column, negative 0.53. So that means that the area that falls below negative 0.53 on the standard normal table is then equal to 0.3. So that means that this thing has to be equal to, so a minus 7 divided by 2 has got to be equal to negative 0.53 or somewhere close to that. Okay, so now how can I find this value? We'll simply multiply by 2 and add 7. So A is then equal to 2 times negative 0.53 plus 7. So A is then equal to 5.94 inches. So the value that cuts off the lower 30% from the rainiest 70% is simply 5.94 inches.